In this tutorial, we're going to talk about dimensions and the dimensional analysis, and we're also going to talk about units and how to transform between different systems. Well, dimensions is the concept, is the basic concept of measurement. It's an expression of measurement. And we can have length, we can have mass, or we can be talking about temperature, or we can talk about other kind of dimensions such as velocity, acceleration. All of them are dimensions and are given by numbers, something that you measure. But then again, in order for this to have a meaning, you need the units. So this is the way you express the dimensions. Length is measured in meters or feet. It depends on the system. Mass can be in kilograms, can be in pound mass. Temperature can be in Fahrenheit, degrees Fahrenheit, degrees Celsius. So right now, what we're going to talk about is about the dimensions, but also any expression that you have has to have a dimensional consistency. The length, the mass, the time, the temperature, the amount of substance, which is mole, those are basic dimensions. And the ones that are derived are, for instance, force, energy, power, pressure, volume, which are derived from the basic ones. So remember, in physics, force was mass times acceleration. So that means that this is going to be from a basic and actually derived. So remember that velocity was length per unit time. So this is derived from two basic dimensions. There are two systems of units, one which is international, and the other one is the English system. And remember that in the international system, the length is in meters, while in English system we have it in foot. The mass here is in kilogram, while here we have it in pound mass. The time is in seconds in both of them. That's good. Temperature is Celsius, or in an absolute scale, Kelvin, while in the English system is Fahrenheit, but in the absolute scale is Rankine. The amount of substance here is in mole, while here is in pound mole. We're going to be transforming from international to English system, and there are conversion factors that we're going to be using along the course. It is very important that any given expression has a dimensional consistency. Let's say that force equals mass times acceleration, right? So the units that you need to input if you are in international system or in English systems vary. So here you have kilogram times meter per second square, and this will yield to Newton. You cannot state kilogram times, I don't know, foot per second square, because that won't mean anything. This will not have a dimensional consistency. And here the pound mass, right? The pound force, sorry, in this case, the pound force, right? Also has its English expression, right? Which is actually very different from pound mass times foot per second squared. This is not correct, and then we need to analyze how to do this English system equation. But any given equation has to have a dimensional consistency, and this is very useful because if you know how to do this dimensional analysis, you can find the units of any given expression.